For radical equations, there are 4 steps that you need to follow in order to solve for x. So what I mean by radical, the first step is you want to isolate the radical term. That just means that you want to get the square root stuff by itself. So radical is just this right here. It could be cube root, it could be fourth root, anything that has a root, you want to get that by itself. Then you want to raise to the appropriate power, so you want to eliminate the stuff under the root. So if I have the square root of x, the way to raise it to the appropriate power would be x squared. Or if I have the fourth root of x, raising it to the appropriate power would be to the fourth power. So that's just going to eliminate my radical. Solve for x and then check for extraneous solutions. So to check for extraneous solutions, you just plug back into the original. So plug back into the original equation. So we're going to do a few examples together. You can follow along. For this first one, we have the square root of x equals 20. The radical is isolated already because I have this stuff over here, square root of x. If I were to raise it to the appropriate power, that would mean that I want to square each side. Because whatever I do to the left, I also want to do to the right. So when I square square root, it just becomes x equals 20 squared, which is 400. Good. Then I want to check it. So when I check, that means that I plug it back into the original. So the square root of 400 equals 20. 20 equals 20. We're good. The next one we have a plus 100 equals 25. The radical is isolated. It's by itself. So raising it to the appropriate power, I'd want to square each side again. So whenever I square the left side, I get a plus 100. A plus 100 equals 25 squared, which is 625. And you can put that in your calculator if you aren't sure. Then I want to solve for x. So when I solve for x, that means that I need to subtract 100 from each side. So I end up getting a equals 525. Then I want to check my solution. So I'm going to plug it back into the original. And the square root of 525 plus 100 equals 25. The square root of 625 is 25. 25 equals 25. We're good. Next example, kind of like number 1. In order to get rid of this square root of y, I want to square each side. So y equals 169. You can plug that into your calculator. Then I'm going to check my solution. So I want to check it. Square root of 169 equals 13. 13 equals 13. We're good. So this would be my final answer. This one, kind of like the second one that we did, my radical is isolated, so square each side. And you get m minus 10 equals 121. Now I want to solve for m, so I would add 10 to each side. So m equals 131. Now I want to check. So the square root of 131 minus 10 equals 11. Equals 11. So this works out. The next one, I have this plus 3 on one side, so I want to move that over so that I can isolate the radical term. So I'm going to subtract 3 from each side. So when I do that, I end up getting the square root of 2x minus 1 equals a negative 3. Then I want to raise it to the second power, so I want to square it. That will cancel. So I get 2x minus 1 equals a positive 9. Solve for x. So add 1 to each side. 2x equals 10. So x equals 5. And I want to check it. So I'm going to plug that in to my original. So the square root of 2 times 5 minus 1 plus 3 equals 0. The square root of 9 is 3 plus 3 equals 0. So here is where I have an extraneous solution. This is not true. So since 6 does not equal 0, I get an extraneous solution. So my final answer would end up being no solution. Okay, we're going to try another one. I want to move this over to the other side, so subtract 1 from each side. 3x minus 8 equals 2. Raise it to the second power. So 3x minus 8 equals 4. Add 8 to each side. Divide by 3, so x equals 4. But I want to check it. So I'm going to plug in x equals 4 into the original. So 3 times 4 minus 8 plus 1 equals 3. 12 minus 8 plus 1 equals 3. So 3 equals 3 works out. So x equals 4 is a solution. Here is something different, and I want you to add this to your notes because it's something that you'll run into on the homework. You have two radicals. You have two radicals. If I divide by 2, nothing really happens. There's nothing further I can do to simplify. So I want to get rid of, or I want to eliminate these radicals. So I'm going to first square each side. When I square the left, that means I need to square the 2, and I also need to square the radical. So it would become 4x plus 3 equals 2x minus 1 when I square each side. Then I want to distribute this 4. So I'm going to rewrite this as 4x plus 12 equals 2x minus 1. Then I want to solve for x, so I'm going to subtract 2x on each side. So 2x plus 12 equals negative 1. Subtract 12. 2x equals negative 13. x equals negative 13 over 2. Then you could check, but I'm going to just tell you that it ends up working, so we're good. Number 8, I want to isolate the radical, so I'm going to subtract 4 on each side. And you have the cube root of x equals negative 5. So the opposite of a cube root is taking a cube, so raising it to the third power. And you can type that into your calculator, but you end up getting x equals a negative 125. The reason why it stays negative is because it's like taking negative 5 times negative 5 times negative 5. So you do these first, you get a positive 25 times a negative 5, which ends up getting a negative 125. So it's like a negative times a negative times a negative. It stays negative. And you can check your answer. So the cube root of negative 125 plus 4 equals negative 1. Negative 5 plus 4 equals negative 1. Negative 1 equals negative 1. Check. Next one, kind of the same thing. So I'm going to subtract 5 on each side. So if I take the fifth root, the appropriate power would be raising it to the fifth power. Since it's an odd exponent, so on all odd exponents it stays negative, on all even it becomes positive. Negative 1 to the fifth power, you could even type that in your calculator if you want to check. You end up getting negative 1. Subtract 6, x equals a negative 7. Then I want to check my answer, so I'm going to come over here. The fifth root of negative 7 plus 6 plus 5 equals 4. Negative 1 plus 5 equals 4. 4 equals 4. That checks out. Here we have a number that's in front of the radical. I want to get rid of that first before I raise anything to the fourth power, so I'm going to divide each side by 3 first. And I'm going to rewrite this as the fourth root of x minus 7 equals 1. Now I can raise each side to the fourth power. X minus 7 equals 1 to the fourth power is still 1. Add 7 to each side and you get x equals 8. Now I want to check it, so I'm going to come over here, check my answer. 3 to the fourth root of 8 minus 7 equals 3. 3 times 1 equals 3. The fourth root of 1 is just 1. 3 equals 3. So x equals 8 is the right answer. This one, I want to move the 2 over, so subtract 2. The sixth root of x equals negative 2. Raising it to the appropriate power would be taking it to the sixth power. So then you would end up getting x equals a positive 64. And you could even take that and put it in your calculator. It's going to get you 64 positive. Then I want to check it. So do not forget to check. If I plug it back into the original equation, I get the sixth root of 64 plus 2 equals 0. The sixth root of 64 is 2. then you end up getting 4 equals 0. That is not a true statement. So this is an extraneous solution. So your final answer would be no solution. Okay, one last one. I have two radicals that they also have the same power. They're both the 7th root. So since they're the same, I can raise each side to the 7th power, and they will cancel. And I can rewrite this as x minus 2 equals 2x plus 1. And then I can solve for x. So subtract 2x. Add 2. Negative x equals a positive 3. So x equals a negative 3. You could even check that. So if I want to go back into the original and check, the 7th root of negative 3 minus 2, negative 6, equals the 7th root of 2 times a negative 3, negative 6 plus 1, be negative 5. Since these two are not the same, you should end up getting the same thing. Since they are not, then that means that this is extraneous. And so the final answer would be no solution. So always, always, always make sure that you check, because if you do not, then you could get a solution that doesn't work and you're going to get the answer wrong. So moral of the story, always check for extraneous solutions.